So Unit 4 is more about liquid equilibrium, solid vapor equilibrium, and osmotic pressure. Let me show you the syllabus. Okay, can you see this? Can you see this?
Yes, sir.
So Unit 4 is phase equilibria. Equilibrium and stability we have already done in phase Unit 3. Now we look at liquid equilibrium, solid liquid equilibrium, osmotic equilibrium, and thermodynamic consistency. So units 2 and 3, 1 and 3 are very long. It took a long time, but unit 4 will not take so much time. Okay. So let's start with unit 4. We'll start with consistency test and then we'll move to other topics. Okay. So consistency test is essentially a test of data, thermodynamic data which we collect in lab, and we need to do that consistency test to find out whether data which we collect from experiments do they satisfy the thermodynamics or not. Essentially Gibbs duhem equation. Okay, so discussion columns are generally based on VLE data, and we have been looking at VLE so far under ideal conditions, non-ideal conditions, and we are using some data to calculate distillation column diameter and height. That means designing the distillation column, which you will do in B project. So we need to have accurate data, and consistency test is used to check the data accuracy in this based on Gibbs duhem equation. There are some 4 or 5 methods of checking consistency of data, and we'll look at all of these. So the first one is using slope of L, and equation 1 is essentially Gibbs duhem equation, x1 ln gamma 1 by double ln x1 by double gamma x1 at constant temperature and pressure is equal to x2 double ln gamma 2 by double x2 at constant temperature and pressure. And for a binary system, we know that x1 plus x2 equal to 1. So x2 is equal to 1 minus x1, and dx1 plus dx2 equal to 0. So dx1 is equal to minus dx2. So if you substitute this in equation 1, you'll get equation 2. The left hand side is the same, the right hand side is essentially minus because of this term. This minus is coming here. And x2 is equal to 1 minus x1, and double ln gamma 2 by double x1. This x2 is replaced with x1. Any questions on equation 2? Okay. So what we got ln gamma versus x1 and measure slopes of tangents at different x values. Okay, we'll see that how it is done. Then if Gibbs duhem equation 2 is satisfied, both slopes, that means this slope and this slope should have opposite signs because there's a minus sign here, right? If they are equal, left hand side equal to right hand side, then the slope should be of opposite signs. Then only this equality will be satisfied, right? And if the slopes have opposite signs, then we substitute in equation 2, and if equation 2 is satisfied, then data are consistent at that value of x1. We'll see that. Let's see. Let's look at the data. So let us look at ln gamma versus x1 curve. This is ln gamma 1, this is ln gamma 2. Now we draw a tangent at any point along the curve and take the slope. So suppose we take these two tangents at this composition, then we get this slope of ln gamma 2 is positive because the angle is less than 90 degrees, and the slope of ln gamma 1 is negative because slope is between 90 to 180 degrees, right? So this is positive, this is negative. That's what we said here, first condition. Both slopes should have opposite signs. That means this equation is satisfied, Gibbs equation is satisfied by this data which is shown here, and hence the data is consistent. Is this understood? Any questions on this point, first method, which we are looking at for data consistency? Okay, if there are no questions, then let's move forward. Okay. Then next point is, we look at this plot of ln gamma versus x1. We have ln gamma 1 and we have ln gamma 2. And what we'll observe is that suppose there's a maximum in one curve, at the same value as a minimum for the other curve. So ln gamma 1 has a maximum at this point. At the same point, ln gamma 2 has a minimum. That is the second condition we'll see for consistent data. So either they are in opposite sign, like in the first case, this is the first case. And the second case is if there's a maximum in the data at the same value of composition, the other ln gamma curve should have a minimum. Any questions? Okay. So if any ln gamma curve has a minimum or maximum, then the other curve must have a minimum or maximum. So when there is maximum in one curve, the other curve will have a minimum. When there is a minimum in one curve, the other curve will have a maximum. That's what we saw here, right? This curve has a maximum, this curve has a minimum. So if you take this curve as minimum, this curve as maximum. Okay, so these are second condition, and the third one. Okay, so let's look at inconsistent data. When will data become inconsistent? So if I look at this data, ln gamma 1 versus ln gamma versus x1, right? So ln gamma 1 has a maximum at this point, this composition, whereas ln gamma 2 has a minimum at a different composition, not the same composition, and hence the data is inconsistent. Another set of inconsistent data, we'll see what is the condition for that. Let's see. Okay, so we have seen that the slope should have opposite signs, right? Here it was positive, here it was negative. Now if you look at this data, what are the slopes like? Ln gamma versus x1. If you draw the slope at any point,
Negative.
right? So if this is, sorry, and if I plot, so slope is what? Slope is in the both the cases it's negative, right? So slope is, and this slope is also negative, right? So we saw that condition that if one is positive, the other should be negative. In this case, both are negative, and hence the data is inconsistent. Any questions on this test? One is slope. Slope should be opposite. Or if the slope is not opposite, then if there's a maximum, there should be minimum at the same condition. If it's a different composition, maximum and minimum, then it is inconsistent data.
सर
Yeah.
सर ये वाली कंडीशन दोनों मतलब सेम मैक्सिमम पॉइंट पे क्यों चाहिए? मैक्सिमम और मिनिमम सेम पॉइंट पे क्यों चाहिए? तो क्या होगा?
That is mathematics now. That is coming from this equation. That is coming from this equation. उसका derivation देखना पड़ेगा. I don't think we need to go into that one. See क्या होता है? If you take this slope, right? Maximum का कब होता है? When do you say you get a maximum at any point in for any value? Maximum
When
minimum.
its derivative is
Second derivative is
first derivative is 0.
first derivative 0. Okay. Or what else? Is there what is the other condition for maximum and minimum? Mathematics है ये. How do you
Okay,
find
sir.
maximum or minimum value? याद है किसी को?
मतलब
secondary
मतलब सर मैक्सिमम
minimum so that
आवाज कट रहा है निरंजन.
the second derivative should be minimum so that the value will be maximum.
Yes. For a maximum, the second derivative should be minimum, and for a minimum, the second derivative should be, sorry, it's not minimum. For a maximum, second derivative should be negative, and for a minimum, the second derivative should be positive. This is from maths, right? याद है?
मतलब सर कंसिस्टेंट के लिए मैक्सिमम की वैल्यू अगर 2 होगी तो मिनिमम की माइनस अब वो कंसिस्टेंट होगा.
नहीं, not that. The slope for maximum.
तो हम कैसे प्रेडिक्ट करें?
If you look at what is the mathematical condition for a maximum, maximum का है कि कर्व का जो second derivative रहेगा, that should be negative. and minimum के लिए second derivative should be positive. That is the condition for maximum and minimum. That is coming from maths, which you should remember, right? So if I look at maximum, minimum, at maximum, what is the value of first derivative?
Zero.
Should be negative.
What is
For
value?
first should be zero.
First derivative is zero, right? मैक्सिमम पे हरदम जीरो रहेगा, यहाँ पर भी और यहाँ मिनिमम पे भी. Right? So first derivative is zero. That is always the case. Second derivative क्या होगा अभी? If I take the first derivative at every point and plot it against x1. So if I take and versus x1, I plot it, right? Versus x1. So I should get, at a maximum, I should get negative value. That means it should be below this curve. If it is zero, it should be somewhere here. And for minimum, it should be somewhere here, right? So that is coming from actually mathematics. I'm not going to show the derivation, but take it for granted that this is the condition. Derivation है, but अभी मेरे पास यहाँ नहीं है. So let's not worry about the derivation. Understand that it has to be following this condition, that if there's a maximum, there should be minimum. Then only the max or minimum, then only this condition is satisfied, or the Gibbs Duhamel equation is satisfied.
Yes.
Okay. I have it somewhere, but not right now. यहाँ पर notes में नहीं है. Maybe I can show you tomorrow. But only if there's a maximum here for this derivative and a minimum here for this derivative, then you can have this equation satisfied. For the time being, assume that this is the condition. कैसे आया? It's a different matter. Derivation अलग है. I can show you tomorrow. Okay.
Yes, sir.
Okay. The other condition is if there is no maximum or minimum, both curves must be positive or negative over the entire range. Right? ऐसा जैसे ये देखा हमने, right? यहाँ पर this is positive and this is negative, right? That is second condition यहाँ पर जो आ रहा है. If no maximum or minimum, then both curves must be positive or negative over the entire range. ऐसा नहीं है कि एक positive है एक negative. That means if gamma 1 is greater than 1 or ln gamma is greater than 0, ये ln gamma plot कर रहे हैं हम, right? ये ln gamma. Ln gamma 1 is greater than 0, ln gamma 2 should also be greater than 0. इसका भी derivation अभी मेरे पास नहीं है, but I can show you tomorrow. So that is second condition. If ln gamma 1 is and if ln gamma 1 is less than 0, that means gamma 1 is greater than 1, तो gamma 2 भी greater than 1 आएगा. Gamma 1 less than 1 रहा तो gamma 2 भी less than 1 आएगा. Okay, this is the second condition. So if these conditions are satisfied, then the data is consistent. ठीक है. By the time you understand the conditions, I can show you the derivation tomorrow for that. Yes, sir. Okay, any questions on these conditions? How they look? दोनों पॉजिटिव रहेगा, दोनों ऊपर आएगा यहाँ पर, then it is consistent. दोनों नीचे आएगा तो एक ऊपर एक नीचे आया तो इनकंसिस्टेंट रहेगा. Okay, if there are no consistencies, let us move to the second consistency test using data at midpoint. That means at x1 midpoint of composition is x1 equal to 0.5 and x2 equal to 0.5. So if you use integrated form of Gibbs-Duhem equation, or Venn-Lahr equation is nothing but Gibbs-Duhem equation after integration. So this is the equation 3 and 4 are Venn-Lahr equations for ln gamma 1 and ln gamma 2. And if you put x1 equal to x2 equal to 0.5, what you will get? ln gamma 1 is equal to a into 0.5 square upon denominator में a by b into 0.5 plus 0.5 whole square. If we take out 0.5 outside the square in the denominator, we'll get 0.25, 0.25 ऊपर भी आ जाएगा, cancels out, and what you get is a और denominator को हमने add किया, so what you'll get is a into b square upon a plus b whole square. So if we take b here on the left hand side, we get ln gamma 1 upon b is equal to ab upon a plus b whole square. ठीक है. Similarly, if you take ln gamma 2 equation and substitute x1 and x2 equal to 0.5, we will get similar equation, which is ln gamma 2 upon a is equal to ab upon a plus b whole square. Okay. Any questions on equation 5 and equation 6? If you compare equation 5 and equation 6, you'll see that right hand side is same, ab upon a plus b whole square. So left hand side has to be equal. So what you get is ln gamma 1 upon b is equal to ln gamma 2 upon a is equal to ab upon a plus b whole square. Okay. So now we consider some cases with values of a and b. Suppose a is equal to b. These are constants of Venn-Lahr equation. So if a is equal to b, if you substitute in this one, so you get ln gamma 1 is equal to, if you substitute a equal to b, we'll get a upon 4. You put a equal to b, this is a square. Again, a plus b is 2a whole square. So what you get is a upon 4. Similarly, if you put a equal to b, you get ln gamma 2 is equal to b upon 4 or a upon 4. It's the same thing. So essentially both are same. Ln gamma 1 is equal to ln gamma 2 and nothing but constant upon 4. Okay. Any questions on case 1? Okay, so let's see case 2. So if we assume a is equal to 2b, and if we substitute again in this equation a is equal to 2b, what you get is ln gamma 1 is equal to 2b upon 9. You can substitute and see whether you get 2b upon 9 or not. करके देखो equation 7 में. Try it out yourself and see if you get 2b upon 9. किया किसी ने? कर रहा है कि नहीं कोई?
यस सर.
क्या किया गया?
सर एक मिनट.
Everybody will try it out.
सर मेरा सिर्फ 2/9 आ रहा है, बी नहीं आ रहा है।
ऐसे नहीं आएगा रे, अरे देखो ये बी है नहीं चाहिए, ln gamma 1 upon b है ना, ln gamma 1
हाँ
upon
सर,
b है ना,
हाँ सर आप समझे।
तो b आएगा ना वहां से।
यस सर, 2a/9 आ रहा है।
राइट, सिमिलरली ln gamma 2 will come 2a/9 बिकॉज डिनोमिनेटर में ये है ln gamma 2 के, राइट। राइट हैंड साइड 2/9 आएगा, लेकिन यहाँ पर इधर से ये आएगा और इधर से p आएगा। And we can say that when we say 2 upon 9, 2 upon 9 is approximately, you can say it is 1/4. This is slightly less than that, but we are just saying it okay, for approximation, we can, because we want to come to some conclusion, right? So it is approximately equal to b/4 or a/4. Okay, case 2. So now let's look at case 3. So assume that a is equal to 3b. Again substitute करके देखो क्या आता है values. A equal to 3b in equation 7. Try it out yourself.
यस सर, 3/16b ln gamma 1 इक्वल टू।
So 3/16 भी आया और 3/16 ही आया, right? So again 3/16 is again close to 1/4. 4/16 1/4 होता है, 3/16 is close to that. Approximation कर रहे हैं हम. We say that it's close to b/4 और a/4. ठीक है. So summary क्या है? At x1 equal to 0.5, then gamma 1 is approximate 4 and approximate equal to a/4. ठीक है. That's the conclusion. Now if you look at Venn-Law equation, equation 3 and equation 4, and we assume x1 tends to 0 and x2 tends to 1, तो क्या होता है, ये सब्स्टिट्यूट करके देखो इसमें इक्वेशन 3 में. Substitute x1 tends to 0 and x2 tends to 1 in equation 3 and find out what we get.
सर ए
क्या आता है? ये आता है, right?
ln gamma 1 इक्वल टू a।
Right, if we substitute now x2 equal to tends to 0 and x2 tends to 1 equation 4, what will you get?
b सर, ln gamma 2 इक्वल टू b।
Right? So what you get is ln gamma 2 equal to b, right? And Siddhi है क्या? Siddhi, are you there?
Yes, sir.
Right, this is what was there in the hint, right? आपकी प्रॉब्लम में.
Yes, sir.
This is what we had to do. जो आपको दिया था कि at infinite dilution, when you say this is tending to 0, that is infinite dilution. That means very low concentration of x1 and x2, and similar this is also infinite dilution. That means very low concentration of 2 in 1. So at infinite dilution, that means at very low concentration of 1 in 2, ln gamma 1 is equal to a, and again at infinite dilution of 2 in 1, ln gamma 2 is equal to b. So this is the way of finding out. आपके जो प्रॉब्लम था सिद्धि, यहाँ पर इन्फाइनाइट डाला था, राइट? दिस व्हाट इज कॉल्ड इन्फाइनाइट डायल्यूशन. ठीक है, समझ में
हाँ सर.
So when we say when ln gamma 1 and superscript infinity, that means concentration of 1 in 2 is very low, and that is called infinite dilution. बहुत बहुत कम concentration है. Similarly, ln gamma 2 and superscript infinity, that means very low concentration of 2 in 1, and that is called infinite dilution of 2 in 1. So now we can conclude for consistency test, ln gamma 1 at x1 equal to 0.5. What we have seen is ln gamma 1 at x1 equal to 0.5, right? ये देखा था हमने, right? Is equal to b by 4, बराबर? ln gamma equal to b by 4 at x1 equal to 0.5. So ln gamma 1 at x1 equal to 0.5 is equal to 1 by 4 into b. B is nothing but ln gamma 2 at x2 tending to 0. That means this is nothing but, ठीक है?
Yes, sir.
Right? Similarly, we can look at ln gamma 2 at x1 equal to 0.5. We have seen that ln gamma 2 at x1 equal to 0.5 is a by 4, right? So if you put it here, 1 by 4a, a is nothing but ln gamma 1 infinity. That means x1 tending to 0, that's why it is infinite dilution. Is this understood? This is second way of testing for consistency.
Sir,
Yeah.
सर ऊपर हमने लिखा था ना कि ln gamma 1 equal to ln gamma 2 equal to b by 4 equal to a. वो दोनों
So that was for case 1 when a is equal to b. Now we're looking at general case where a and b can have any value. Right? उससे हमने summarize किया कि ln gamma 1 is approximately equal to b by 4 and ln gamma 2 is approximately equal to a by 4. We are not saying a is equal to b here because we have taken three cases. First case was a equal to b, second case was a equal to 2b, third case was a equal to 3b, right? इससे हमने जनरलाइज किया कि it is approximately a by b by 4 and a by 4, not equal. Equal होता है only when a is equal to b. बाकी केस में it is not
Yes,
equal.
sir.
बस ln gamma 1 is equal to b by 4 है यहाँ पर, ln gamma 2 equal to a by 4 है यहाँ पर. Only in the first case it is equal, right? So it is not, we are not taking a specific case, we are taking a general case. A and b can have any value.
सर तो मैं gamma 1 के इक्वेशन में b equal to by 4 भी डाल सकता हूँ ना
हाँ?
सर a equal to 2b का जो केस है ना उसमें ln gamma 1 में a equal to 2b डाला तो वो b के फॉर्म में आया तो मैं b equal to a by 2 भी डाल सकता हूँ ना
See, this is just a case we are looking at कि ठीक है, values of a and b can be what? It can be that a is equal to b, a equal to 2b, a equal to 3b. उल्टा भी किया हमने, suppose b equal to 2a, तो क्या हो जाएगा? उल्टा हो जाएगा ना, और क्या हो जाएगा? Instead of b, you'll get a here. We're just looking at general case कि what are the likely correlations, what we get ultimately. Ultimately what we get is ln gamma 1 is approximately equal to b by 4. Hello, can you hear me?
Yes, sir.
Yes.
Yeah, network बीच में चला गया था. So what we are looking at is essentially a general case now. वो specific case हमने लिया था A equal to B, A equal to B, A equal to B and A equal to B वगैरह. Just to see कि what are the likely values of ln gamma 1 and ln gamma 2. That was the only reason. We are not going to. Just a minute, huh? ठीक है. So what we have done is we have taken some examples कि A equal to B और B का correlation क्या होगा. A equal to B, A equal to B, A equal to 3B वगैरह लेके just you come to conclusion कि हमारा likely correlation क्या है gamma 1 B के साथ और gamma 2 का A के साथ. And now we are taking a general case in which we see that ln gamma 1 at infinite dilution is equal to A and ln gamma 2 at infinite dilution is equal to B. And now we are coming to a conclusion that ln gamma 1 at x1 equal to b equal to 0.5 is nothing but 1/4 the value of ln gamma 2 at infinite dilution. Similarly, ln gamma 2 at x1 equal to 1/4 the value of ln gamma at infinite dilution. This is general case. Doesn't matter a और b का values क्या है. This is general conclusion. तो हमने स्पेसिफिक केस लिया था कि देखने के लिए कि क्या कोरिलेशन हो सकता है. ठीक है.
Yes, sir.
So what we get is ln gamma 1 or 2, whatever it is. I can put I here. Is equal to 1/4 the terminal value of the other ln gamma curve, right? So gamma 1 लिया, right? When I take gamma 1, यहाँ पर gamma 2 है. When I take gamma 2, यहाँ पर gamma 1 है. Understand this, right? So ln gamma I is equal to 1/4 the terminal value of the other ln gamma curve, right? 1 लिया तो 2 का आएगा right hand side में, 2 लिया तो 1 आएगा right hand side, right? That means the curve which is highest at end point will be lowest at midpoint. We will see that. Now let us see that consistent data क्या होता है, inconsistent क्या होता है. So if you look at ln gamma versus x1 and we take value at 0.5, right? So A equal to B case लिया था हमने, so they will have the same value ln gamma equal to ln gamma 2. हमने देखा था, right? A equal to B का case. In this case ln gamma 1 was equal to ln gamma 2. ठीक है. This is case 1. In this case, if you get this type of data, that means ln gamma 1 equal to gamma 2, ln gamma 2 at x equal to 0.5, then it is consistent data, right? Now if b is greater than a, हमने जो देखा था, right? b is greater than y कहाँ था? यहाँ पर b is less than 1 है, but ठीक है, it doesn't matter. Okay. So in other cases, what will happen is when you say ln gamma 2 equal to 0.5, so if I look at this one, ln gamma 1 at 0.5 and ln gamma 2 at infinite dilution. That means this value, right? Okay. This is ln gamma 1 at 0.5 and this is ln gamma 2 at infinite dilution. Okay. So what will happen is, what is second condition? Curve which is highest at end point will be lowest at midpoint, right? यहाँ पर जो highest है यहाँ पर end point पर, right? End point is this side. यहाँ पर जिसका ज़्यादा है वैल्यू वो यहाँ पर कम रहेगा midpoint पर. Then only that condition will be satisfied that this is equal to 1/4 the terminal value. This is basically from geometry. इसका proof of नहीं है यहाँ पर हमारे पास. We have to take it that okay, this is the only way that data will be consistent if this value at the midpoint is higher than this value at midpoint. Then only this value will be what do you call it? Let's see. Okay, yeah. So this is not the value we have to see. We have to see this value. Sorry. We have to see this value. And this value. So what we are saying is ln gamma 1 at x1 equal to 0.5 is equal to ln gamma 2 infinity. That means x2 tends to 0, x1 tends to 1, right? So ये value जो है, right? This value should be 1/4 the value of this, and that is possible only if this value is below this. Geometrically वो कुछ prove किया होगा उन्होंने. I don't have the proof of that, but we will take it as that. ठीक है? समझ में आया? This can be one fourth of this value can be equal to this only if this curve, this value is less than this value. Otherwise not. Geometrically prove किया होगा. I don't have the proof of that. ठीक है? And inconsistent data कब होगा? When it is opposite. Right? Yeah.
सर कर्सर से बताओ ना सर, थोड़ा कंफ्यूजन हो रहा है कौन सी वैल्यू.
ln gamma 1. This is ln gamma 1, right? At 0.5. ये वैल्यू है 0.5 का. Now this is equal to हमने प्रूव किया
Yes, sir.
कि 1/4 the value of ln gamma 2 at infinite dilution, right? ln gamma 2 at infinite dilution, that means x2 is 0. This is x2, x1 है ये, right? And x1 equal to 1, x2 equal to 0, right?
यस सर।
सी की ये जो वैल्यू है इसका, यहाँ पर जो वैल्यू है जो हाईएस्ट है इसका 1/4 वैल्यू विल बी दिस इक्वल टू दिस वैल्यू। वो कब होगा? व्हेन दिस कर्व इज पासिंग थ्रू दिस बिलो दिस मिड पॉइंट कर्व। ज्योमेट्रिकली प्रूव किया होगा उन्होंने कि इट्स पॉसिबल ओनली इफ दिस वैल्यू एट मिड पॉइंट इज लेस देन दिस वैल्यू एट मिड पॉइंट।
ओके सर।
ओके, वी डोंट हैव द प्रूफ ऑफ दैट, कहीं बुक में दिया भी नहीं है। पहले वाला भी प्रूफ बुक में नहीं दिया था, जो हमने देखा ना कंडीशन, जो मैं बोला देता हूँ बाद में। बुक में नहीं दिया डेरिवेशन, बट ओके आई कैन शो यू टुमारो। इसका पता नहीं मेरे को। सो वी आर टॉकिंग अबाउट इनकंसिस्टेंट डेटा कब होगा? व्हेन यू टॉकिंग अबाउट ln gamma 1 at midpoint, this value is below this value। बस हमारे को वही चाहिए ना, ln gamma 1 at x equal to 0.5 should be 1/4 the value। यानी ये वैल्यू जो है it should be 1/4 the value of this thing। और अगर ऊपर रहेगा तो पॉसिबल नहीं है। सो ज्योमेट्रिकल दे मस्ट हैव प्रूवन दैट दिस इज द केस। इफ दिस इज द केस, अगर ये नीचे आ रहा है ln gamma कर्व, gamma 1 कर्व above below ln gamma 2, then this is not possible, then it is inconsistent data। ठीक है, सो वी हैव टू सी कि कौन कौन सा कर्व नीचे आ रहा है। अगर gamma 1 ऊपर है तो ठीक है, gamma 1 नीचे है, gamma 1 नीचे है तो ठीक है, gamma 1 ऊपर है तो रॉन्ग है। नहीं, gamma 1 should be above, sorry, gamma 1 curve should be above gamma 2 curve at midpoint, then it is correct। if gamma 1 curve is below gamma 2 curve at midpoint, then it is wrong, inconsistent data। ठीक है, so let us move to the third method। it's called Redlich-Crystal method or zero area method। so we can use this method when activity coefficient data is available over the entire range। पूरा वैल्यू में 0 to 1 के रेंज में x gamma values available है। okay, so this is based on free energy। what is excess Gibbs energy? Essentially it is free energy of mixing of real solution minus free energy of mixing of ideal solution। and we have done this derivation before। delta G excess is equal to RT summation of x1 xi ln gamma I। ये derivation हमने किया है पहले। so we can write this equation for binary system। delta G excess is equal to RT x1 ln gamma 1 plus x2 ln gamma 2। and we can write x2 as 1 minus x1, and then we differentiate this equation 6 with respect to x1। what we get is d delta G by dx1 is equal to RT, and if you take the derivative, there is two functions, first function into second derivative second plus second into derivative first। ln gamma 1 पहले आएगा, dx1 by dx1 is 1 minus ln gamma 2 because x2 is equal to minus x1 लेंगे हम, right, plus x1 into dln gamma 1 upon dx1 plus 1 minus x1 into dln gamma 2 by dx1। ठीक है, सो दिस माइनस एक्स है और ये प्लस एक्स है, ये कैंसिल हो जाएगा ये टर्म। ओके, एंड व्हाट विल गेट इज बाय यूजिंग गिब्स ट्यूम इक्वेशन x1 dln gamma 1 upon dx1 is equal to x2 dln gamma 2 upon dx2। again same thing, x1 plus x2 equal to 1 and dx1 equal to minus dx2। we have seen this x1 ये पहले भी किया, राइट? या minus 1 minus x1 dln gamma 2 upon dx1। so if you combine these two, what we'll get is d of delta G by dx1 is equal to अच्छा, ये जो टर्म है, ये बेसिकली आई एम सेइंग दैट ये जो टर्म हम यहाँ डाला है हमने, इसकी वजह से ये कैंसिल हो गया। x1 dln gamma upon dx1 is equal to minus 1 minus x1 dln gamma 2 upon dx2. So ये जो टर्म है, not because of this x1 and x2, ये दोनों टर्म कैंसिल हो जाएंगे because of this equation 9. So what we get is RT ln gamma 1 upon gamma 2 on the right hand side. ठीक है, equation 10, is it okay? Okay, so now we will integrate equation between x1 equal to 1 to x1 equal to 0 to 1. x1 equal to 0 is pure component 2 हो जाएगा, and at x1 equal to 1 it's pure component 1, right? So for pure components there is no mixing effect, right? We have seen that it's only for solutions there is a mixing effect. That means delta GE is equal to 0 at x1 equal to 0 and at x1 equal to 1. For pure components there is no excess because it is basically free energy of real solution minus free energy of ideal solution. यहाँ पर solution है ही नहीं, pure component is pure component, so it is 0. Delta G is 0 for pure components, right? So if you integrate, what you get is integral again d delta G by d delta G limits में 0 0 रहेगा नीचे ऊपर because of this thing, and right hand side में integral 0 to 1 RT ln gamma 1 upon gamma 2 into dx1, यहाँ से नीचे dx1 इधर रहेगा on the right hand side. Left hand side is 0 and right hand side में RT is constant. Integral 0 to 1 ln gamma 1 upon gamma 2 into dx1. Right? So what we get is essentially integral ln gamma 1 upon gamma 2, RT इधर आ जाएगा 0 हो जाएगा, dx1 between 0 to 1 is equal to 0. That means this integral should be 0 for consistency. So what we do is plot ln gamma 1 upon gamma 2 versus x1 and calculate area under the curve between x1 equal to 0 to x1 equal to 1 limits में. So this area under the curve should be 0. Then the data is consistent. ठीक है? Okay. So if you plot this ln gamma 1 by gamma 2 versus x1, you'll get something like this curve. So area under the curve above 0 is positive. Area under the curve below 0 is negative. And if this positive and this negative are same, then total area is equal to 0. Area under the curve is equal to positive area plus negative area. And this should be equal to 0 for consistency. ठीक है? Any questions on these methods? ये मेथड्स में जनरली शॉर्ट नोट्स ही आता है और ज़्यादा डेरिवेशन दिखाने का नहीं रहता है. यू आर आस्किंग फॉर डेरिवेशन, आई कैन शो यू दैट टुमारो फर्स्ट वाले का. बट व्हाट दे वांट इज एसेंशियली व्हाट आर द कंडीशंस. व्हेन डू यू से द डेटा इज कंसिस्टेंट? व्हाट इज द कंडीशन टू बी सेटिस्फाइड फॉर consistent data? Derivation is not important, conditions are important. Okay?
Yes, sir.
Okay, so timetable change है अपना. Tomorrow again we have lecture at 9 AM.